So let's talk about another new terminology or jargon in the matrix determinant world, which is called as cofactor or cofactors of an element or cofactor of a matrix or a determinant, however you want to say it. In the last episode, we must have covered another jargon which was minor of an element. If you guys remember, we discussed about minor of an element and what is a matrix of minors, and we are just going to continue on that line. So what is a cofactor of an element or matrix of cofactors? So if you recall in the last episode when we discussed the matrix of minors, for the time being when I was trying to explain, I asked you guys to ignore this algebraic signs which were like goofy and which were in certain places and which were not in certain places, all these things over here. I asked you to ignore for a reason, because the very fact that these algebraic signs are assigned to some of the spots within this matrix is nothing but the effect of cofactoring or cofactor. That's what it means. You cofactor it, apply, have a factor or give a company to this factor by putting this algebraic sign. And let's discuss why it is done and how it is done. Okay, let's talk about cofactor. Okay, cofactor of an element comes in play when you multiply minor of an element, or for the matter, you take the whole matrix of minors, which is denoted by capital letter M, and you multiply each of the minor of the element within that matrix either by a plus 1 or a minus 1 in a particular order or a pattern. And whatever net result you get, that is either cofactor of an element or cofactor or matrix of cofactors, based on if you're taking one element to start with or you're taking the whole matrix of minors to start with. And now let's break down this. What do you mean by multiplying it by plus 1 or minus 1, and that too in a particular pattern? What are we talking about? Okay, so this is what we're talking about. So let's say you have a 3 by 3 matrix like over here. Let's take this example and then jump back and forth. Let's say we have a 3 by 3 matrix. It could be 2 by 2 matrix also, does not really matter. Let's say we have a 3 by 3 matrix here. Okay, and what we're going to do is, let's say we want to multiply, and let's say this is not a matrix, this is a matrix of minors. So there was already original matrix, let's say original matrix A, and then we found out the matrix of minors as M based on the minor of matrix formula that I taught you, and we have created this matrix of minors. Okay, now we have created this matrix of minors. So matrix of cofactors or cofactor of each of this element is nothing but multiplying each of this element. Certain elements will be multiplied by plus 1 and certain elements will be multiplied by minus 1. And which are the elements that will be multiplied by plus 1 or minus 1 is given by this cheat sheet that I call, which kind of gives you a hint on how to do that. And since you just want a cookie cutter approach, I'm just putting it here without explaining you the logic behind this. If you want to know why this and how did this come from, check out my other videos on pure intuition on where this came from. Okay, so this cheat sheet tells this very positional. So whatever element is in this position, first row, first column, will be multiplied by plus 1. So I've removed 1 from here because it's self-explanatory, but you can assume that it should be multiplied by positive sign of plus 1. Whatever is in this position, which is first row and second column, should be multiplied by negative 1. So in essence, if you see this matrix, what it gives, if you see here, elements on both the diagonals, this diagonal and this diagonal, are always multiplied by plus 1 because they have plus signs. And all the remaining elements, this and this and this, these 4 remaining elements in a 3 by 3 matrix will be always multiplied by negative 1. That's what applying cofactoring to a matrix of minor means. And you can follow this simple rule. Instead of remembering how to alternate the signs, you can just remember this rule. This is what it is here. So if you see here, we are taking a matrix of minors as input. We are going to apply the logic of cofactors, or we are going to cofactor this whole matrix of minors to give us a matrix of cofactors. And what in essence we are doing is, for each of these position elements, we are just applying or multiplying by plus 1 or minus 1 based on the position. So in essence, if you see all the diagonal elements, this diagonal, the principal diagonal, as well as the second diagonal, if you see this, they do not undergo any changes. If the incoming number is positive, these numbers stay positive. In the incoming number over here is negative, they stay negative. If you see here, the diagonal elements do not undergo any change. It stays as it is. Whereas the four non-diagonal elements, or in this 3 by 3, or they could be less in a 2 by 2, whatever is the non-diagonal element, if you see that, that will have a negative opposite effect. If the incoming number or element is positive, in the outcoming or in the matrix of cofactors, it will be negative, and vice versa. For example, if you see here, over here this number is positive, whereas here this has become negative. Over here this number is negative, over here has become positive. This number is negative, this number has become positive. And this number is positive, this number has become negative. That's what cofactoring means, or that's how you build a matrix of cofactors. Either you can take one element at a time, or you can take the whole matrix, does not matter. As long as you apply the simple logic of alternating plus or minus sign. A lot of textbooks also explain in that way, that you alternate the plus or minus sign, plus, minus, plus, and so on and so forth. So whatever comes to you can use that, whatever is easy for you. The way I do is, whatever is on both the diagonals, those are positive and remaining are negative. That's how I apply it. But even alternating positive, negative also is fine. But make sure that you always start with a positive sign and you alternate from both the sides. You alternate here also and you alternate here also. So that's what a cofactor means, a matrix of cofactor means. And a matrix of cofactor is denoted by the letter C. How matrix of minus is denoted by the letter M. Moving on to a couple of more examples to get more clarity on matrix of cofactors. Let's take this whole matrix here, which I have put as cofactor of a 3 by 3 matrix with we have all the variables from A through I. And if you recall from the matrix of minus that we did in the last episode, this is what we got, and we are going to use the same logic over here, where we're building, this was built as the matrix of minus, and this already had the cofactors baked in, but I asked you to ignore for that for the time being, because I was explaining the matrix of minus. But the same thing we are copying here in terms of building it. So we have built it. So each of this element is a cofactor. Sorry, each of this determinant is nothing but minor of the respective elements in this original matrix, which is given to us. Let's say this matrix is given as A, and this becomes a matrix of minors. So this is M, and when you guys throw this algebraic signs in the mix, this whole effect is nothing but a matrix of cofactors, right? So without this sign, this signs, this is just a matrix of minus. But when you add these signs over here, the alternating plus or minus sign, then this whole matrix becomes a matrix of cofactors. And what it is doing is, we first calculate the minor of each of the element. For example, this small puppy is the minor of element A. This puppy is the minor of element B. This one is for C, and so on and so forth, where we don't include the very element, just how we discussed in the minor, when we learned how to find a minor. So we are not including the element for which we are finding the minor. So we are just putting the rest of the determinants. So the determinant itself, each of this determinant, which is like a small submatrix, in this case it's a 2 by 2 submatrix, and in other cases it might be a different order. So each of this piece is called as a minor of the element. And when we add or multiply it by the algebraic signs of multiplying it by +1 or -1, using this cheat sheet I've given it to you, when you add that, the whole matrix becomes a matrix of cofactors, because now it is signed. And the simple formula is, all the diagonal elements will be multiplied by +1. So there will be no change. Whatever is the incoming number in terms of sign, it will remain as it is. And whatever is the 4 elements which are not on the diagonal, this piece, this piece, this piece, and this piece, if you see, all of them have negative signs, because over here, over here, and over here, and over here. That's what cofactor is all about, as simple as that. So we can also see the same thing if you're used to, in terms of using not all the variables, but a single variable, but with transcripts on row and column number. The same thing. this piece is nothing but minor of the element A11. Just this piece is nothing but minor of the element A32, third row and second column, and so on and so forth. So if you just remove the signs, then it becomes, the whole thing becomes a matrix of minus. But if you add this, negate this, or multiply it by -1 here, 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 and here, if these four elements which are on the not on the diagonal, if you, once you sign the whole matrix based on this cheat sheet that I have discussed, then this whole thing becomes matrix of cofactors. That's all it means, nothing more, nothing less. So hopefully this was clear. We have demystified two jargons: a minor of an element and cofactor of an element, and we have one more to go, and then we'll do some other. We'll get back to determinants and how to compute this determinant, because we are not discussed that far. This piece, what is the value of that? We know the value of that is a number. It could be positive, it could be negative, or it could be 0. But what is the number and how do you compute that? We are not come to that. So that will be coming up in the next 1 or 2 episodes. Stay tuned then, and I'll see you in the next bite.